Hi friends, Naji here. Welcome to my YouTube channel. So we are continuing a discussion on LangGraph memory, and in this video we'll be discussing on long-term memory. So we actually discussed on or just mentioned what is long-term memory in a couple of videos back. So in this video we can discuss more about this. So long-term memory is a cross-thread memory to store user-specific or application-specific information and useful for application like chatbot to remember user-specific preferences. So in a short-term memory, we are using the thread-based memory. So if we change the thread, we will not able to get the previous thread data or previous thread details in that particular context, right? So instead of that long-term memory, which is a cross-thread memory, we will able to save user-specific information across the thread. Okay. Then the key points that we need to remember. So long-term memory have a namespace and it should have a embedding model. So we can see like why we need, or we can discuss more about why we need these things. Okay. So namespace is help us to make the long-term memory specific to a user. Okay. For example, I can create a namespace with the user ID, which will help me to make the particular namespace only for that particular user. Okay, consider the chatbot example. So each and every users have their own preferences, right? So somebody is like a black theme, or somebody is like would want to see the chat in a like a yellow screen or blue screen, something like that, right? So in that case, we can make it unique to or that specific namespace only for that specific user. So the embedding model is used to do a similarity search to get the information from the long-term memory. So there are different long-term memories are supporting, like Redis is we can use, and we can also use the Postgres, but in this training purpose we will be using the in-memory store. So we can start building some long-term memory and we can discuss more about this. So here I am going to import few things. As I mentioned, like I can create the embeddings and I can use init embeddings. Okay, it's working. Okay. Now I can have a LangGraph. From LangGraph store dot memory we can import in memory store. Okay, so once that is done, now I can create the embeddings. So embedding can be initialized using init embedding. Here I am going to use OpenAI. We can use the text embedding 3 small. Okay, so let me execute it. Good. So we have our embeddings ready. Okay. Now let me define a store. Store can be defined as InMemoryStore. Here I can pass two things. One is the embed. This is our embedding. Okay. Now I can use the dimension, which is 1536. So the store is also ready. Okay, so here what we need to do, here we have a mistake is that I need to specify the index. So let me specify the index here. Okay. This is the index. Okay, now the store is ready. Now we can manually add some information to the vector store. I mean some information to the store. For that we need a namespace. So let me create a namespace. I'm going to create a namespace for a specific user. Okay, for example, I'm going to create a user 1. Okay, and I'm just saying that memories. Okay, so this is my namespace. Now I can add some data to the store. So I'm going to add store.put. Okay, here I can specify the namespace. Okay, Now I'm going to create a key value pair, and this is the key, and the value that I'm going to give is a text. Here I'm going to say I love pizza. Okay, let me see. It's working. Some issues there. Let me figure it out. Here I have the namespace. And here I have the key is there. In the text I'm saying I love pizza. Okay, maybe the name. Okay, no, the store is not defined. Okay, so let me run it again. Okay, something is not right. Okay, so I'm going to run it again. So let me run all again. Okay, now I have the store. Now let me add some more details to the store, that is the namespace. I can give the namespace, then I can give the 2. This is my key, and the value that I am going to keep is say dictionary. I can say the text. Here I can say I prefer Italian food. I think this is not needed, so let me remove this. Okay, now I can add some more things. Here I am going to make it as a 3. Here I can say I don't like spicy food. Spicy food. Okay, now I can add something more. Here I'm saying that okay, I can add one more thing. I love Japanese food. I can add. Okay, so we have added few things with our vector store or in-memory store. Okay, consider this as a kind of a vector store in between. Okay, now what I am going to do, I am going to search few things from the store. Okay, here I can search that. Okay, here store.search, I can do a search, and here I am passing my namespace. Okay, now I am passing a query. The query is I am saying that I like food, and I can set the limit as 4. So this is done. Now if you look on the memory, we can see that okay, it is actually fetching the details from this vector store. Okay, so here we can see created time, and if you go there, we can see the what we call the score with respect to each vector input. Okay, so in this way we can insert to a store and we can get the value from the store. So we are good now. Now we can see how can we implement this with the LangGraph. So I believe that everybody understood about this particular concept. Then we will see how we are going to implement this into LangGraph. Okay, for that we can build a LangGraph, very simple LangGraph. Okay, for that let me import few packages. I can import chat, init chat. Okay, so this is, sorry, not chat loaders. I am expecting chat models. I can import init chat models. Then I need to have a LangGraph store.base. We can import base store. Here we have the graph. We can import start, message state. Now we have the state graph. Let me have the LLM. I can initialize a chat model. Definitely I am going to use OpenAI model. I can use GPT 4o mini. Okay, now I'm going to define a chat function. Okay, so for that I'm expecting a state. I can have a store also. Here I can mention the base store. Okay, so this is the function. So what? Okay, let me make it a pass. Okay, because otherwise it may little confuse. So let me complete the code. Okay, now let me build the graph. So I'm going to build a graph. Here the state graph, the message state is the state. Now I can add a builder dot add node. Here the chat will be a node. Now I can have a edge. So the edge will be start and the chat. Okay, so this is my graph. So we have only one node chat, then we have the starter node and the ending node is there. Okay, it's a very simple node that we are using here, that is a chat. So the chat is what we are going to build next. Okay, so what is actually we are trying to achieve is, if somebody asks a question, okay, what we will do, we will do a query search. Okay, then we will fetch the data from the vector store or from the in-memory store, then we will give this as a context to the user. Okay, so LLM will get more context and it will try to it will able to create more relevant answers. Okay, so for that what we can do, first we can take the message. Okay, so the message will be, I know that in a state I have the message, right, from the messages. So I'm going to take the last one. Okay, so I will have my message here. So this is here, I can print that my message or my query. Okay, here I'm going to give the message. Okay, so once that is done, okay, what I will do, I will take the items from this query. Okay, for that what I can do, I can use the store dot search. Okay, the same thing, I can use the same namespace and the query will be the message. Okay, then what I can do, let me make it query dot content is needed, then I can make a limit which is equal to 5. Now we are going to create the memories. So this is we will have a set of information will be there in our hand and we are going to join these informations, right? So I can use a join here. Okay, so what I will do, I will be iterating to these items, this item in item. Okay, I know that this item have the value, item dot value, I can take the text from it. Okay, now here I can print my memories. Okay, so we got the memory. Okay, so once we have the memory, what we will do, we will give this as a prompt to the model. So I'm going to say memories prompt. Here I can mention here, I will tell this is my memory, memories of user. Here I can say that, okay, this is my memories. Okay, here maybe I can add one more check. If memories is only there, I can pass, otherwise I can pass empty. Okay, now we can invoke the LLM model. So here I'm going to trigger invoke, right? Now in the invoke I can pass two things, right? One is my role is system. Okay, now I can pass the content. So in the content I can say that you are a helpful assistant, then I can pass my memories prompt. Then next, what we will do, we will pass whatever there in the state message. So let me complete this by returning the messages. Response. Okay, now let me execute it. Okay, so I believe this is clear. So let me explain it again. So what we are going to do, what we have done is we take the last message, okay, that I'm just printing that. Then based on that message, we are going to query that. Okay, so we are taking the message to content, then we are going to take the take items from that, then we will have the item. Then from that we are just joining that, so we will have a list of items, and that item will be, we are passing as a system prompt. Okay, so in this way the LLM have some context about the memories. Okay, so now going back to here, so let me add a compile here. Let me build a graph. We can have a builder.compile. Here I can pass the store. Similar to checkpoint, here I can pass the store. Okay, building now. Just do a for loop. I have metadata in graph.stream. Right, here I can have an input. Input can be messages. Here I can pass the role. Role will be the user role. Now similar to that I can pass the content. Okay, now here I can pass which food do I like. Okay, so this is my question. Here I can make a stream mode as messages. I can print the message dot content, not count, it's content. Let's make it like this. Okay, now let me execute it. So we are getting an error, but we can investigate it. But here if you look on this, my message or my query is which food I like. Okay, so this is my query. Then my memories, I don't like spicy food, I love Japanese food, I love pizza. Okay, so I'm getting only 3. Let me check this. Here we can see I don't like spicy food, I love Japanese food, and I prefer Italian, and I love pizza. So somehow I love pizza, only 3 is shown up here. Okay, then we got some error. Let me check this error. Invalid model ID, invalid request type. Okay, let me check the model, the LLM model that we have selected. GPT-4o mini. Here you can see init chat model, OpenAI. Let me check spelling is correct. GPT-4o mini, spelling is also good. Okay, so the error is due to the initialization of our model. So actually we don't need this space here. So let me correct the space, let me remove the space, and let me run it again. Okay, so I am running all the cells again. We'll see. Okay, so here it says you like Japanese food and pizza. Okay, this is our final answer. You like Japanese food and pizza. Now let me go and see like the answer is correct. So I'm going back. So here I mentioned I love pizza. Then here I mentioned I love Italian food, but somehow that is not in the result. Okay, so this is because when I copied, I didn't forget to change this. So let me correct this. Now run it again. Okay. Okay, so now I can see you like Italian food, Japanese food, and pizza, and you also prefer non-spicy dishes. Okay, so now it's able to get my preferences, right? Okay, now we'll see if how can we insert something to a something to our store, right? So for example, I can just do some corrections here or some modifications here in my chat. Okay, so there are different ways that we can do, but this is just for the sample. So what I'm going to do, I'm going to check if message dot content, if this is start with remember. Okay, then what I will do, I will take the message, will take the content. Now I will remove the remember, then I will select everything, then I will strip it. Okay, so after the remember, this is what it does is, after the remember I will select all the text. Okay, if something is there, if remember is there, or if my query start with a remember, then I will take all the text after the remember. Okay, then I will store this into namespace. Okay, I can make this as a index as a 6. Okay, then as we did, I can add the text here, I can add the text. Okay, now we'll see what will happen. Okay, now let me execute this and execute this, execute this, execute this. Starts, not start with, it's a starts with. I'm trying to, okay, here this is. Executing again. Okay, now I'm saying that remember I like apples. Remember I love apples. Okay, so what this does is it will come to here. Okay, and it will check, okay, any word is starting with remember, then it will take the text and it will store into the memory. Okay, so we'll see. Now let me execute it. Okay, so it says, okay, oh, got it, you love apples, and there are some messages there. Now I am going to ask the same question again. Which food do I like? So here I can say you like Italian food, Japanese food, pizza, and apples. So the apple is there. Okay, because it is saved, so we saved that into our store. Okay, so this is, I have done this for the example. So here we can do our own logic to insert the data, and there are tools, built-in tools are available. So as a start, we can practice like this. Okay, so yep, so that is all about in this video. So in our coming videos, we can discuss more about lang memory, and we can discuss how this can be integrated with a create React models or create React agents, and also we can discuss about the built-in tools, that is the built-in LangMem SDK also, that we can discuss in our coming videos. So please do like and subscribe. Have a nice day. Bye bye.